The first thing you should do is to divide both sides of this equation by 36, and you get what I've written in here in red, right? So this is the equation, and hopefully you understand that this is the equation of an ellipse. The center is not the origin, as you may expect. It's x minus 3, and so you have the horizontal translation by 3 and the vertical translation by 2. The center is 3, 2, right? And then because of these numbers, 9 and 4, you can see that the semi-major axis is horizontally, and it's 3 and horizontal, and it's 3. The semi-minor axis is of length 2, and that goes vertically in the y direction, and the length is 2, and so on. Okay, so this hopefully is the picture you drew, and we are trying to find the area of this ellipse. At this point, I don't expect you to be able to figure out what U and V should be, but that's okay. I want to let U be x minus 3 over 3, okay? The reason is because what you see here is simply U squared, okay? By the way, this can be written as 1/3 x minus 1. V is the other one, y minus 2 divided by 2, okay? So that way, this will be simply V squared. So in other words, this equation will be U squared plus V squared is equal to 1. That's something that we can handle, right? All right, so this equals 1/2 y minus 1, okay? So here, this is really easy. You don't even have to set up a system of equations at this point. Why is that? Well, because now, remember, in order to solve for the Jacobian, I have to find out what x and y are. Well, 3u is equal to x minus 3 and 2v is equal to y minus 2, right? All I'm doing is multiplying this first line by 3 and second line by 2. And so this will give you that x is equal to 3u minus 3 plus 3, sorry. Y is equal to 2v plus 2, okay? Can you find the Jacobian now? Sure, the Jacobian, remember, is xu, xv, yu, yv. And so this is 3. And of course, x has no v included, so this will be 0. And then yu, well, y has no u, but y has 2v, so this will be 2. And this is actually 6, right? That is the Jacobian. Hopefully you got that far. All right, so what happened is this is the XY plane, right? Now, in the world of, I guess I should not be doing this. I will draw what happens. This is the region R, okay, what we described. Now we're going to be in the UV world, and we're going to integrate this. Okay, did you get this? In the world of X and Y, the thing that we were trying to describe is an ellipse, okay? But in the world of U and V, the region of integration turns out to be defined or surrounded by the same equation, except using U and V. That's U squared plus V squared is equal to 1. What is that? Well, that is a unit circle, the unit circle in the UV plane, right? We are asked to integrate, well, I mean, this is the area, so the integral, the integrand is just 1, okay? So what we want to find is this, the area of R, okay, which was the integral on region R, and the A in the XY world, right, in the XY plane. Now we have another way of describing this. This is the region S, okay? Because U squared plus V squared is equal to 1. That is the correct region, S. And then we have to have, well, there's nothing there's no function F, right? So, I mean, if you have to have an integrand, it's basically 1. You don't have to have that. But then you have to put the Jacobian. The absolute value of Jacobian is, of course, 6. And then you do dA. Well, this is just 6 times the area of S. You get that? Right? So what is the area of the unit circle? Well, that's just pi times 1 squared. So the answer happens to be 6 pi, okay? And so that is the answer to the question I asked, what is the area of this ellipse? And by the way, just so you know, okay, if you have an ellipse, I will give you the, in general, This is a footnote, okay? The example is done. The example, the answer is 6 pi. But in general, we have a formula for an ellipse. Some of you may know this. Okay, so anytime you have an ellipse, you have what we call the two, it's not radius, but you have this A and B, right? A is called the length of the semi-major axis, and B is the length of the semi-minor axis. The area of an ellipse is always, it's just going to be AB times pi, okay? And you can tell this is a more general version of the equation of a circle, right? In a circle, A and B are both R, so you have pi times R squared, okay? This is something that you could also get by different methods. And you may have seen this in calculus too, right? So this is exactly how you calculate the area of an ellipse. And so I already knew, or if you had known this equation, you already knew the answer would be 6 pi because it's 3 times 2 times pi. All right. Now, so this is the end of section 5.7 and also the end of chapter 5. But I told you that you have seen this kind of a transformation before, going from a UV plane to some other, an XY plane to some other plane. And so that's what I just wanted to conclude this section with. All right, so BTW, by the way, okay, so the Jacobian, you've seen this before. Now, where? Well, one transformation you've done is this transformation between the rectangular coordinate system to the polar coordinate system, right? Okay, so let me explain what I'm talking about. In polar coordinates, x was r cosine theta, right? Y is r sine theta. Okay, so you had an equation like this, and maybe I will talk about a specific region in just a second. So guess what the Jacobian is? All right, Jacobian, in this case, you can think of r as your first variable like u, and theta is like your second variable theta. And so this is your Jacobian, right? Well, what's the partial of x with respect to r? That's cosine of theta. And how about x with respect to theta? That would be negative r sine of theta, right? And then how about y sub r? That would be sine of theta. And then y sub theta, that would be the partial of y with respect to theta. That's r cosine of theta. You take the 2 by 2 determinant, that's r cosine square theta minus negative r, negative r sine square theta, okay? And of course, this is just r times cosine square plus sine square, which is 1, right? And so this is just r, okay? So you remember dy dx, so you had an integral, of f dy dx over r. This is now, you can write this as a new area S, and then you can write f in terms of r and theta. And instead of dy dx, what did you put? Yeah, you had r dr d theta. This r is actually, yeah, that was the Jacobian. We didn't call it the Jacobian, right? And geometrically, what you're doing is this. See, you had a picture like this. Let's say your r was this a quarter of a circle of radius 2. So theta goes from 0 to pi over 2, and r goes from 0 to 2, okay? Well, in the world of, so you went from the world of xy to the world of r and theta, and all you're really doing is you're integrating as r goes from 0 to 2, and theta goes from 0 to 2, pi over 2. That is a rectangular region in the r theta plane. Right? And so you can do that, except you have to insert that Jacobian in there, which was that r. Okay, so that's what's happening here. One more thing I should mention in this last thing, Jacobian was 6. And as you study linear algebra, you may have seen this, but the determinant has to do with the area ratio. Okay, so 6 is the difference, or it's a ratio of the area here in the world of UV and the world of XY. All right. In other words, compared to the UV world, as you go from the UV world to the XY world, which is the correct way to, it's the right direction. It's the T, um, the direction of the transformation, the area, the size becomes 6 times as big. All right. So this area here was pi. Area here is going to be 6 pi. This is the factor by which you would have to multiply, and that's pretty typical in what the determinant is going to show you. And you will see a hint of this as you take linear algebra, I think. All right. So yes, you have seen one example of this without knowing that this was the Jacobian. We are not going to use UV substitution much more. In fact, this may be the only section where you need to know this, but hopefully you've understood how to extend the U substitution idea to the UV substitution idea. All right, so that was section 5.7. Again, you may be worried like, man, I really don't know if I understand this. Don't worry too much about this. You will not be asked a lot of questions from section 7. You have like 8 homework problems, and half of them are really straightforward. Maybe a couple of them you may have to spend some time on, but that should not be too difficult, okay? So that would be the end of chapter 5. And until I see you next time, I hope you have a great week. Take care of yourself. I will see you later. Bye.